execution that can be involved with multi-steps, with actions. We're going to talk about actions in a minute. And batch mean and executions that can end up or start with a voucher. Voucher is the element that in charge for transferring funds between different chains. Creating a voucher means depositing funds into a contract that later will be claimed by the same signature on a different chain. And on that case, you actually get the bridging transfers from one chain to another. What else we have on the concept stage? Beside actions and batches, there is a multi-chain concept. Since we're dealing for the first time properly in code with multiple chain, the idea is to create in code entities that will be involved with more than one chain. In that case, a contract should be handle should be aware of different chains and to handle multiple addresses in case this exact same contract is available on more than one chain. So let's go a bit about this stuff, just like to get you what we have, and about the plan for today. So first, the idea is to show how easy it is to have a new protocol involved in any system that based on EIL. In that case, we're going to get a couple of elements in order to make it happen. First, as I mentioned, actions are basically the building block of execution on EIL. The SDK, the EIL SDK already provided some of those. A basic action to call contract, an action to call ERC20 approval, transfer, native token transfer, and so on. But this is like very few of what can be done. What we did actually, part of this demonstration, but also of building Stitch that Ivo going to show in a couple of minutes, is we build a logic that involved with multiple chain and multiple protocols. So in that case, the architecture that we had is to have each execution or each step that we want to have that relates to a DeFi protocol as an action. And in that case, once you have action for deposit, withdrawal, stake, wrap, unwrap, and so on, you can later make a logic that involve with them and make the great experience that we have in with EIL that involve with multiple chains, multi-step, but with a single signature. And so we're going to see how I'm going to create an action, okay? But for that, this action, by the way, will be add liquidity to Uniswap, okay? An action that involved with two actually different tokens, and calling the Uniswap router, okay? Before that, we're going to create the entity of Uniswap router and anything that relates to that, okay? And of course, at the end, we're going to see it running with an example of USDC from Arbitrum and USDT from Base, navigated into Ethereum, and then executed as an add liquidity call to Uniswap, and in between we're going to get ERC20 approval for both that is required for the third action. Okay, down to code. So we're going to see, so let's open, and I'm going to show around what we have. Fine, so maybe I'll put it a bit more larger. So what we're going to have. So first, this is what already implemented. You can see the following protocols already supported. We have Morpho and Limitless and Lido and Eigenlayer and BFI and Aave and so on and so forth. And we can see that each one of them, if you check Aave, for example, it's involved with all the elements that I just mentioned. We're going to create the same for Uniswap liquidity pool deposits. So let's start first. So as I said, we're going to have an action, but before the action, we need to have a contract. Factor is right now unrelated, but I want to have a contract. In that case, I already predefined the addresses of the Uniswap router, okay? Per chain. Address per chain is actually an entity that already, a type already provided by the EIL SDK. And once I defined each one of those, we can check, for example, that this one on Ethereum is already here, okay? So we have the contract address, we mapped per chain, and then next we're gonna create the router ABI. Already set it up, but as easy as it sounds, it's about going to the, we can use Etherscan, go to the ABI, just copy it, put it over here, and this is considered done. So we have the ABI set, and we have the addresses, as you saw already, set. And now we're going to create a multi-chain Uniswap router, okay? Luckily, we have AI here involved, so once I'm doing export class, you already recognize that this is what is required. And you can see that we basically inherit from multi-chain contract, okay? That is a class involved with that actually represent a contract in EIL SDK. What is expecting as parameters for the constructor is the client, because we want to execute through this contract. It also requires the ABI, as we already defined, okay? And it also requires the addresses map that we saw in advance. Side comment, we don't necessarily need to have all chains supported. It's enough to have one. One is actually a bit irrelevant, but more than one is probably will demonstrate the case that we are having or talking about multi-chains. So, and later we will see that if we need to use this kind of contract, we need to validate that this contract supports this specific chain. So, we have a router. So in this case, this router can be used in order to fetch the contract, to execute, to use it for any other type of execution that involved with this router. So once this is done, the next step will be to create an action. So you know that we're gonna have, we're gonna go for add liquidity, right? And as you can see, add liquidity has a lot of parameters. So I'm gonna skip that, like doing this like manually. I'm gonna check it out over here and show around that how it's look like, how the action should look like. So we see that it's inherit from base action. Base action means an interface that eventually have an encode call that will get you the encoded call data to be executed. So, and it can be like also a map of call data. But in our case, once we want to have such an implementation, then we'll see that we need to fetch first all the parameters that we need, okay, on the constructor. That means the router, of course, the receiver address, okay, token A, token B, amount desired for A and B, if needed, min A and min B, that is part of the add liquidity call, and a deadline. In that case, once we have it, the encode calls actually means to format this as an encoded call object and get the exact execution on its way. Of course, args will be the same order as we know from the contract itself. Function name, very straightforward, and it actually supports VM SDK as we know. So that should be like super transparent to any Web3 developer, and should have it to use, ready to use very simply. So again, back to what we had. We had a multi-chain Uniswap router defined. We had the Uniswap liquidity action in place. That means get me the parameters, and from that point, I know how to encode an EVM standard call. And once we have that, now we can use it and make this thing function. I pre-created a test for it that will be in a way gonna take us, as I mentioned, through the entire journey cross-chain from USDC from Arbitrum and USDT from Base to Ethereum, and then deposit or add liquidity into Uniswap. So basically, putting such execution in place should again be something that is very straightforward to who is involved in the blockchain space. We create a builder that is the most fundamental element on EIL execution that is already there. And of course, an account that represents the user account. Later, Ivo will show us how it looks on the UI and how Ambire Wallet implemented that for the users. And the parameters that we want to have, amount desired, and for token A, token B, deadline, as we saw parameters. This is for test reasons. We're going to fetch balances before we do the execution and after and see the balance change. And now we're going to see the creation of a batch. Remember, a batch represents an execution on a specific chain and can be involved with creation of a voucher. So here we can see a create batch that is only involved with add voucher request. Add voucher request is an action. We learned that the actions are actually the steps of execution on EIL SDK. So what we actually saying over here is that create a voucher of USDT token with the desired amount means that I wanna take out of Arbitrum USDT on this specific amount. And later we're gonna see also a batch that someone will claim it. Sorry, we're gonna do the same for Base and USDT, creating a voucher, a batch that involved with only a single step of creating a voucher for USDT on Base. And on that case, what we will see is that we're gonna see funds moving out of Arbitrum, USDT actually, and USDC from Arbitrum, and USDT from Base, and USDT from Base. And what is missing will be the next step where we use all voucher. This is the Ethereum mainnet batch creation. And we're gonna see, on that case, use all voucher means claim or get all the funds that were involved in the voucher creation on the other chains. And we're gonna see the funds moving into this chain, and then we can use it. The next step for us will be an add action for approving USDC, part of the requirements for liquidity addition. Yes, it's actually having the before that an approval for the two tokens that involved in this action. So we have an approval action for USDC with the relevant amount, and we're gonna have approval action with USDT for the approval amount. In this case, we put max value, but definitely it should be set as like specifically what we want to have on this execution. And the last one of this action is Uniswap add liquidity action that we just created with all the parameters that we mentioned before, Uniswap router, account addresses, USDC, USDT as token A and token B, amount desired, min amount for both, and a deadline. We're going to execute that and see the balance change accordingly. Now, since we have a lot of connectivity issues, we're going to hope for the best and see that running. And I hope I didn't forget anything. Yes, of course I did. And second. Okay, we have that in place. Now let's run it. Make sure that it's functioning. Hope network will be on our side. No, it's not. It's actually failed for timeout. Anyway, we had all predefined some action that I already ran it before, like an hour ago, when I have like optimal connectivity. So I'm going to show that instead. And first, this is we part of the project of building Stitch and also involved with DeFi implementation for EIL, an extension. We created an explorer that involved with all chains supported. So in this case, we can see that we have the Ethereum mainnet actions that are 3 of them. We see the approve, 2 approvals, and the last one is add liquidity. We see on base actually none, just the voucher creation, and the same goes for Arbitrum, that is a voucher creation and approval for probably the related stuff. And now if we want to check how the execution look like, we can take this this user op. Where the TX hash? Okay. You can take this TX hash. Before this, we built the entire environment, 4 chains on Tenderly VNets that will be also used for the hackathon, the EIL project on the hackathon, on the ETH Global Hackathon. So we have it already. And on that case, we can see an execution on Ethereum, and we can check for this specific handle op, user op, and of course, okay, we got it. So let's shortly review what we have. We can see that, I don't know if it's like visible enough, but we can see that we have, of course, since it's account abstraction based, we see the entry point and we see the cross-chain paymaster and all of that. But we can see also that the null address, this line, is actually involved with issuing liquidity tokens of Uniswap. If we go to Etherscan and put this one over here, so you can see that Uniswap V2 ERC20 token pool is created and transferred into the user. This is the user address. The user also got on Ethereum a bit of USDC. That's because when you deposit into a pair, it will take the exact up-to-date balance, and if there are leftovers, they're just going to remain on the account wallet. On this case, we have 4, and we see that only 3.005 got into the wallet. So in that case, we had 4. Some remains on the user wallet, and some got into the Uniswap V2 pair. What else? We can go to dev mode and see like the exact execution, but I will skip that stage, that step, and can have this like ignored for now. But as you can see, we see that what happens on Ethereum, on the destination chain that is Ethereum, is actually exactly what we need. We had the transfers appears from the cross-chain paymaster. We see that the deposit made into Uniswap V2 pair, and the same amount that we defined. And on that case, it's actually exactly what we want to have. So that's kind of it for us. That means, back to this, we managed to create exactly a multi-step involved with more than 5 actions into this, made it exactly the way we want to, and it's a matter of a couple of minutes. Of course, I know this is like I did it in advance, so it's easier for me, but imagine that it's involved with any basic fundamental smart contract wallet involvement. Now, Ivo going to show us what we build with Stitch, and going to take us through the impact of this on user experience with Ambire Wallet.
Sure. So this is Stitch, the app that Ofir implemented, and it's the first app to really use the Ethereum interoperability layer. And I'm from Ambire. I'm going to show you how it integrates with Ambire, which is the first wallet that implements the Ethereum interoperability layer, and the impact for users. So the cool thing about Stitch is that you can use balances across any number of chains without really caring about where this balance is. So it's essentially balance consolidation. So the impact of this is that neither in your wallet nor in the DApp you're gonna see fragmented balances anymore. So if you have USDC on 5 different chains, it's gonna appear just like one USDC. And you can see a perfect demo of this over here, where balances are consolidated by network. We have this very cool feature that we can actually peek into the underlying distribution of balances. So we can see that we have like a ton of different wrap tethers, ton of different USDCs, and etc. And by default, if I just use USDC from here, Stitch will decide, or the Ethereum interoperability SDK actually will decide automatically where to use the balance from. But just for the sake of the demo, I'm gonna either like use all of the balance, ensuring that it hits all 3 chains, or I'm gonna pick them manually. To show you like essentially the future, what I'm gonna do is I'm gonna allow it to pick automatically. So I'm gonna enter 22. I have 10 on 3 different chains, so 22 must hit 3 chains. So yeah, it must use consolidation. Then on the output, the cool thing about Stitch is that Offer already showed you all the protocols it implements, and I can plug into any of those protocols. So I can say, put my 22 USDC into Aave, let's say. Now it's loading a quote, and if the internet is good enough, we should get it working. And yeah, and this is essentially a preview. The user doesn't need to care about this, but each one of those arrows is a separate 4337 user op. And we have some voucher usage here as well in order to consolidate those balances into Ethereum. You can see that we essentially use USDC from 3 different chains. I know it might be a bit tough to follow, but what happens here is we take some from Optimism, we take some from Arbitrum, we put into Ethereum, and then we put them into Aave. So now when we click submit, this is gonna start loading a request to Ambire wallet to authorize all of the user operations at the same time. It's gonna take a while, again, because of the connection. But hopefully, what we're gonna see here is a dialog from Ambire Wallet showing you to authorize all 3 user operations at the same time. And at the moment, it just shows hashes, but clear signing is coming, and this is gonna show you. Oh yeah, it's working. This is gonna show you exactly what you're signing in the future. So it's gonna tell you exactly what you're authorizing with a simulation as well. So it's not gonna look like this. But then when we click sign, this starts working, and essentially all of the user operations get broadcast using the respective bundler on each network. Gas is paid only once, even though we are doing connection across 3 different networks. And hopefully, if we get this confirmed, we are going to show the EIL Explorer. Yes, we have a link go to Explorer, and when this loads, you're going to see all of those operations across all of the different networks that we just interacted with. So yeah, here we have a preview, the same schematic that we saw, and we have the raw code data on Ethereum, the raw code data on Optimism, and I think we had one more chain involved. Yes, Optimism. And yeah, we can see each individual user op and how it translated to an individual transaction. And obviously we can check this in Etherscan if we want, or Arbitrum scan, or whatever. So yeah, that's pretty much it. It feels like magic. It's pretty fantastic. Back to you, Ofir.
Thank you. Cool. I guess we pretty much covered anything. Probably gonna go to questions, if there are any.
One over there.
Yes. Gonna put this. Yes, please.
Am I audible?
Yeah, you are.
Okay. So on your example, I see that you are trying to move $22 worth of USDC and you are putting it into Aave. Am I understanding that right?
Again, 22 USDC, and to put it where? Into Aave, yeah.
yeah. So I see that there is only $12 is the so 10 plus 2 makes it 12. So another $10 worth of USDC is taken from Ethereum chain itself.
Yes, the idea is we have 30. And in that case, we're going to have 10 each. That's the original state. So what we did over here is to translate, to actually transfer 10 from Optimism and 2 from Arbitrum into Ethereum. And then you got the rest of it moving from, it's actually 30 on that case, and move all of it um, into it's actually no, it took already 20, just 22, but it took it from Arbitrum and Optimism. Okay, so it's actually not involved with the funds that were in other places. Does that answer your question?
Okay, but I think my understanding was that you are using
By the way,
22.
I'm assuming the amount could have been a bit confusing. So essentially, you had 10 in one chain, 10 in another chain, and 10 in a third chain. And I showed 22 in order to show a real world scenario because 30 is like too perfect. Because 22 requires taking two just from one chain in order to be able to get that amount. Because if it was 20, then it would hit two chains. Anything more than 20 hits three chains because we had 10 in each individual of the three chains. So I wanted to show a real world example of how consolidation will work.
Maybe you want to have the mic from him.
Even if he has the mic, I don't have the
Okay,
headset,
okay.
but it's fine.
I'll,
I was thinking, how does the chain that like, is there a preference of like we're gonna take 10, 10, and then because like you could have taken 2 from Optimism and 10 from Arbitrum. How does that happen? Like
So
alphabetical order in the
I'm
list
per-
of.
I'm personally not familiar, but
I will explain. This is like
yeah.
EIL, and that's something that can be a bit confusing. EIL is not like an intent solution. It's not building the logic for you. It's actually providing the infra to navigate funds and do this all beautiful one single transaction multi-chain execution. What we build on top of it is to extend the building blocks into more DeFi protocols, and you can see that over here. So you can see all the chains that we already supporting, and actually all the different protocols. But the logic is actually built on top of EAL, us saying that if you have funds on a specific chain, maybe it's better to use it in order to save the gas, or you can define specifically what chain you want to use. So the logic itself built on top of it. I won't say that important it's just like a way for us to demo. What is important is that it's the infra, the EIL SDK makes it super easy to build something like that and let you focus on your exact logic or the use case that you want to support, and not dealing with gas and cross-chain and failures and multi-signatures that are not available like mostly on any other case, and so on, so on, so on. So the idea is that you can build this logic like more properly.
So what I was gonna say is that because I've been thinking about this from a wallet perspective and how to best consolidate it, obviously you want to start working from the destination chain. So if you have funds on the destination chain, not complicated.
Are the docs gonna be up in time for the ETH Global Hackathon on the repos, or we really got to dive deep and figure it out?
Offer, can you
So
repeat the question
the
if that was
question talks about the documents of EIL. So it's already here. It's already published. It's this morning. What is missing? Probably like a Tendel integration that we're gonna have because we build for you up-to-date environment running, but we're also gonna have an additional documentation of how to run your environment, your Tendel environment, and play with that. So it's mostly there. I guess it's probably not perfect because it just launched, but we're gonna be there anyhow, and we plan to have tomorrow a session of explaining how to work with that and what can be done with this and capabilities and what is supported and so on. So make sure to be there, and you're probably gonna get all answers to any question.
Perfect. And And one final question about the stitch, and I kind of asked this yesterday, the answer got cut off and sideways. But I guess I was thinking, like, how does the EIL be aware of like the current value of all of these things and like the quoting or like getting the best price from the wallet standpoint? You have to use something else to do that. Like, can you give me an example of like, is that Zerion? Like, just help me, give me
Yes, for sure, sure.
the stack.
So he's asking about like the data like Stitch is using. I'll answer that because like probably more relevant. You can see, I guess it's like now very common to have to split on any Web3 related app, DApp execution, to actually split read and write. If we are treating blockchain as a database, read and write are separate. So in that case, you mostly deal with one of them. In that case, saying that because EIL is actually for execution. You won't see here any code or like balance between Uniswap pools and so on, because the idea is to deal with execution. Single signature, as I said, having the ability to support easily any protocol, having like the best experience and so on. Fetching can be done like in any way that you can imagine. In that case, we use like very common data providers, like in that case it was um, alchemy and so on. So it's mostly getting the data as as you can. There are some like on this on Stitch, we tried as much as we can to base our data on on-chain data. So it's I'm saying like as a service, alchemy and so on, but for us, the ideal is to get the data on-chain. But in some cases, you cannot do that. Okay. Problems start, by the way, or when you can miss stuff is when you get all kind of protocols that are not really on-chain. Okay. You see, for example, I'll show you something. You see, for example, that we do support limitless. So you can see any scene or any market, I don't know how they define it, on limitless is supported. But now limitless moved to work on a different mode when you talk with their service and not directly with the smart contract. On that case, we have with EIL, there's no value with that, and that's very obvious. So it's kind of unrelated to that. So in this example, you can see that we only support the on-chain element that involved with the limitless.
Oh, that's perfect. And one final question: the EIL Explorer URL. I'm explorer.syndica. Is it?
Yeah, I will share it also. This one, I will share it on the commentation. This is like something Syndica voluntarily did in order to support this project. Because we want to have some kind of an explorer that involved with multiple chains and batch execution or like present execution that kind of unrelated. The connection between the batches or the transactions, user op and so on, is not really on-chain. So you cannot match or connect them like properly. So we built some basic UI just to get it in place. I'm going to share it too. It's going to be available. It's very basic. We're going to extend that into something like more fancy, having the ability to define the transaction of voucher creation or voucher usage and so on. But for now, I guess it's a good start to direct you into the real Explorer and so on. So, cool.
Hi there. I maybe not directly related to EIL, but I'm having trouble understanding the relationship between EIL and OIF.
Ah,
It seems
cool.
EIL is at the bottom of the stack, provides a very simple intent solution, and more complex intent-based solutions are in OIF. Is that correct?
So I'll tell you my point of view about it, because that was mentioned also yesterday when we introduced EL for the first time. Your confusion is actually coming from EIL ability to support intent solution very easily. So since it makes it super easy, it's put you in a position that it's a bit confusing. There's like not much more to do in order to get you an intent solution. Actually, Stitch is an intent solution. You're saying you want to go from here to there. There's like many to many, and the magic happen. And it's built with the UI only, like a logic that runs on a Chrome extension. In that case, EIL is actually the rails for it. It's actually the highway that you want to go through, and all the apps are the cars that riding through that highway. Intent is only one of them. Okay, I guess that's like the definition for it, but it makes it easy for building such solution. I guess that's like the bottom line and the most important message that can be provided here.
Got it.
So I want to add something about this, pretty much kind of the same perspective. They're complementary. By the way, everyone is asking about this, so it's good to clarify, but there is no simple way to clarify without understanding each system in detail. But the thing is, EIL doesn't remove the need for intents, although in practice, because it's this multi-chain execution layer, first of all, and second of all, because it provides a way to move funds across chains, those two things combined lead to intents being less necessary and a classic like third-party solver being less necessary. So in a lot of ways, the wallet can become the solver or the dApp can become the solver, and EIL gives you better primitives to do that. Because if you don't have the primitive for multi-chain execution, then it's really easy to shift this to an intent engine and a third-party solver, and to just rely on this solution. But one example is if I want to bridge funds to another chain, then on the other chain buy an NFT and then send the NFT to someone else. Those are three separate actions. And nowadays, if I want to do those three separate actions with just one signature, then the best way to do this would be to depend on some bridge which has post-operation hooks. And this bridge is definitely not completely trustless because it has to execute some code on behalf of me on the destination chain. Even if I authorize this code, it does have some trust assumptions. And with the EIL, the ability to execute those operations on multiple chains with the same signature removes that dependence on this third-party bridge. And also the ability to move funds between chains with the voucher model also eliminates this need. So in many ways, it eliminates the need for a classic intent system, but in many ways also you can think that first of all, the wallet becomes the solver, the dApp becomes the solver, and finally, some elements of the interoperability layer are intents in themselves. Like the cross-chain paymaster is kind of an intents-like system. The voucher is also kind of an intents-like system. So yeah, it's really hard to explain, but they're complementary.
Got it. Okay.
Great. I guess we are done. Thank you, everybody.
Thank you.